Okay, so in this part here, what we want to do is we want to calculate the volume of each of these. Here I'm going to give dimensions. Okay, this is going to be 10 meters, and we're going to give this some kind of height. Okay, the height over here is going to be 8 meters. And then this line over here, which is the same as that one, is your depth. We're going to give that 20 meters. What we want to do is we want to find the volume of this prism, right? On this side here, we also want to find the volume. And in this case, we're given, let's make this 75 meters. And let's say this height over here is 60 meters. That's the perpendicular height. And this length over here is 120 meters. A pretty big values over here on this side. Now, looking at the example on the left, when we're calculating volume, volume is equal to base area multiplied by depth. Now, the base area can be anything. It can be a circle, it can be a triangle, it can be a trapezium even. It can even be a rectangle. And then from there, the depth is given by the 3D, what makes it into 3D. So the moment I extend this, that's the depth. So each of these shapes can have a single number that makes it into 3D. In this case, the depth is going to be 20. And the area is going to be that of a triangle. And so from this here now, we're going to calculate volume is equal to half times base times height. All right. Because the base area over here at the moment is a triangle. So we get the triangle area and we multiply it by depth. And remember, depth is, I'm going to just call it D for now. Okay. All right, let's jump into this now. We're going to substitute in here. So volume is equal to half times my base. I can see my base is 10. So 10. And my height is 8. And my depth is 20. And we're multiplying across. So we're multiplying the three numbers and then dividing it by 2, basically. So 10 times 8 is 80. 80 times 2 is 8 times 2 is 16. 0, 0. 1600. And half of 1600 is 800. And that's in volume. Because it's meters times meters times meters, it becomes meters cubed. And so the volume here will be meters cubed. Okay. All right, let's go to the next one now. Next one here, I want you to try and see if you can calculate that volume. If you have a calculator, give it a go. Okay, so here we want to find the volume. So this is going to be basically the same formula, but remember we're finding the area over here of the triangle, base area, and we want to multiply it by the depth, and this is my depth. So that's going to be half times base times height times depth. My base is given as 75, so half of 75, that's this number over here. My height is given as 60, that number over there, and my depth is given as 120, that number over there. And so we got to put all of this into a calculator and calculate it. So let's put it on a calculator. And that's going to be 0.5, which is half times 75 times 60 times 120. Straight in the calculator gets me 270,000. All right, so that's 270,000 meters to the power of 3, meters cubed. Okay, and that would be the volume over there. You just calculated the volume of a triangular prism. Now let's move on to the next one. Let's move on to some rectangular prisms. Rectangular prism is the simplest of the lot. It's just length times width times height. All right, so here we got a rectangular prism. I'm just going to quickly sketch one up for you. And you can see that's the front face, the back face, and I'm now connecting all the lines from here. And you can start noticing that we have some kind of length, right? We have some kind of width over here, this length here, this length, this is the width, this is the length, and so this is my height. Height always goes up, all the way up. And the volume is given simply by length multiplied by width multiplied by height. It's as simple as that. Okay, let's draw another one over here. So that the back face, you can see there's another face there. And then from there, and then that'll go down there. From there, we can see that from this here, this is going to be my length. I'm going to write L for length, W for width, and H for height. I'm going to write V equals length times width times height. That's L. Okay. All right. Let's give it some values. Over here, let's give this 8 meters. Let's make this 12 meters. And let's make this 4 meters. And so the volume for this will become length, which is 12. So this is 12 over here, times the width, which is 8. That's 96, times the height, which is 4. And what is 96 times 4? 96 times 4, 384. 384 meters squared would be the volume of the shape. Okay, keeping that in mind, I want you to try this one over here. Suppose this is 14 meters, this is 28 meters, and this over here is 10 meters. See if you can get me the volume. And by the way, what you notice is that meters times meters times meters is meters to the power of 3. So that's meters cubed, not meters squared. All right. Try this question on the right-hand side and see if you can get it. All right, let's go through this one now. So the volume is given by the length, which is 28. That's this number over here. Multiplied by width, which is this number over here, which is 14. Multiplied by height, which is 10. And so we put all of this on a calculator. Put all of this on a calculator. And we're going to end up with 28 times 14 times 10, which is 3920. 3920 meters cubed. All right, 3920 meters cubed. And that's your final answer for that volume of a rectangular prism. Okay. All right. So, firstly, what you notice about this is that the front of this shape is a trapezium. All right. And you can see the trapezium is the shape that we need to find the area of. And once we found that area, we then multiply it by this line over here, which is my depth. Right, so we have to find the area of this front part and then multiply it by my depth, because that's the formula for volume. Volume is area of the front multiplied by depth. Remember, it can be any shape. In this case, it's a trapezium. Let's give the shape a little bit of values now. Let's suppose this is at the moment 20 meters and there's some perpendicular height. Perpendicular means goes 90 degrees. And this perpendicular height over here is, let's say, 10 meters. And the line at the top here, let's make that 12 meters. That's going to be this whole length over here. And this depth over here, let's make this 15 meters. Now remember what we're doing here. We're calculating the area of the front first. And after we calculate that, we're going to multiply it by 15. And that's going to get me the volume. Okay, so let's jump into this now. So volume is equal to area of the front or area of the base of the shape. I'm just going to put area multiplied by depth. Okay, so depth is going to be that. Now the area that we have at the moment is a trapezium. That's this shape in front. And the area of a trapezium is given by half times the two parallel sides added multiplied by the perpendicular height. That means A is over here and B is over here. And that's what we put in here. We're going to make that equal to A, which is 12. And we're going to make this equal to 20. And what we do is we add those two numbers first. Parallel sides. What does parallel mean? It means that those two lines that are running, these two lines are not parallel. Okay, but those two lines are parallel. So look for the parallel sides first and then put those parallel sides in there. Then multiply it by a half. And once you've done that, you now have the area, right? You have the area part. And remember the depth part is just a number 15. And so we add that in afterwards, multiply by 15, and that becomes the volume. And you can see there's the depth over there, right? You can see there's the depth 15. So let's calculate this now. So volume is equal to half. Let's do the brackets first, bad mass. 12 plus 20 is 32. Brackets. And now we have multiplication all the way across. We can use a calculator and we go half times 32 times 15. Let's put it on a calculator. And that's 240. So 240, don't forget this is what we're calculating first. This part over here is meters squared, right? But I'm missing something here. I'm missing the height. Can you see I didn't put the height in there? So this is going to be completely wrong because I didn't get the height in there. All right, so there's an error there. Let's take a step back. Let's take a step back and let's put the height in there. Now, what was the height? What was the height? The height is 10, which means I'm supposed to multiply it by 10, and that would have given me the area over here. And that means I have to multiply this by 10, which means my final volume would have been 2,400 meters cubed. Okay, so let's take a step back. All right, so we end up with area is equal to half A plus B. Let's not forget the H now. We're going to multiply it by H, which is 10. And then we said depth is 15. And we put that in there at the end. Let's calculate it now. A half times 32 times 10 times 15. That's 32, right? And that's going to get me a half of 32 is 16 times 10 times 15. That's where that comes from, 16. So I simply have to multiply by 10. 2,400 meters cubed. That's going to be my volume. Now try this next question on the right here. Don't forget the height now. I'm going to put the height up here. I'm going to make the height 10 meters again, but I'm going to change the base. I'm going to change the base length from 20 into 15 meters. I'm going to change this length into 20 meters, and the parallel side at the top, I'm going to make 10 meters at the top there. So that's 10 meters. That's 15 meters. And that's 20 meters. All right, and that becomes, this is 10 meters at the bottom, yeah. Okay, so this is the height. That's my A, my B, and my D. So let's get me the volume for this shape, and what will the volume for this shape come to. Okay. All right, let's get through this one now. So if I want to find the volume of this shape, okay, remember I've got to find the area of this front part first. Okay, so that's the area of a trapezium. Volume, remember, is equal to area multiplied by depth. So the area is given by half of A plus B times the perpendicular height, because that's the area of a trapezium, and that's the shape we faced with, multiplied by the depth, which in this case would be 20. Now, allocating values here very carefully. Remember that A is 10, B is 15, and H is 10. So this is going to become a half 10 plus 15 times 10. All right, putting each of these values in 10, 10, and 15. The bracket must be done first, then multiplication, and then 20 for D there. So the volume comes to a half of 25 times 10 times 20. Now I'm just using brackets for now, but you don't need to. You can use anything. I'm going to put this on the calculator straight away. It's going to give me an answer from here. So it's going to be 1 over 2 times 25 times 10 times 20. And that comes to 2,500. 2,500 meters cubed. And that'll be the volume of this trapezoid. All right.